Right, so yesterday we did sections 10.1, 10.2. Okay, today we're going to continue on with 10.3. Okay, this section is called values of a function. Okay, values of a function. Okay, can anybody remind me what is a function again? Okay, Mr. Roy just went over that in the homework. What is a function? Yeah?
Okay. So, isn't it when you have coordinates, but then the domains don't repeat?
Exactly. You have a coordinate and there's no value that repeats in the domain. Or you can call it the first coordinate. Same thing.
Remember, it doesn't matter. It doesn't matter if that second coordinate repeats. It doesn't matter. If the important thing is if it's the first one. That's all we're looking at for a function.
Okay, so let's just a review from yesterday. Okay, reminding you what a function is. Okay, one way that we can visualize relations, and we did this last night in the homework, is to graph them. Okay, take all the coordinates and put the dots and make a picture. Okay, kind of like we did right here. Okay, making a picture.
So on your thing you have one, right? So one way to visualize it is graph it in the coordinate plane. So what's highlighted up there. So one way you can visualize a function is to graph it in the coordinate plane. Like we did on the homework last night.
When we're trying to visualize something rather than write it as coordinates, there's several ways we can do it. Right? Today we're just going to look at two. Okay, one of them we've already done. Okay, the other way, okay, so in spot number 2, I want you to write down mapping diagram.
So one way will be graphing in a coordinate plane, and the other way will be a mapping diagram, which we're going to show you guys today. There's already a couple of them. There's a bunch of them already on your notes.
I think yesterday I even drew a mapping diagram, a quick one. I don't think I talked too much about it, but kind of drew some lines between numbers. We'll show you what a mapping diagram is. All right, so we're gonna take this set of ordered pairs, okay, these 4 coordinates, and we're gonna turn it into a mapping diagram. Okay, the way you make it a mapping diagram is you put domain, okay, on one side. Put that on the left. Put range on the right. Okay, what are my values that are in the domain here? Just list off what they are. Victor?
2, 6, -1, and -3.
Yeah, we have 2, 6, -1, -3. Okay, those are the values in the domain. Okay, what about my values in the range? How about Davin? Can you tell me what are my values in the range?
5, 9, 2, 0.
Yeah, 5, 9, 2, and 0. Okay, so what we do is we put all the values in a domain, okay, put kind of a circle around those, put all the values in the range, put a circle around those, and then we're going to connect the ordered pairs. Okay, so you look at 2. What is 2 supposed to match up with? 5. So we draw an arrow from 2 to 5. Okay, the next one, 6 and 9. Okay, we look at 6, it's supposed to connect to 9, so we draw an arrow between them. Okay, sometimes the lines can cross. Okay, depends if you didn't list them in this order. When you connect them, you might have lines crossing. That's okay.
And guys, I see most people doing it on your notes under those 2 things we just filled in, so 1 and 2 with the lines. You have like the 2 brackets to write in all the ordered pairs. I think most people have already done that, but if not, that's what those brackets are there for. You want to put all the ordered pairs inside, and you have a blank mapping diagram below it. Fill in all the numbers.
Only 3 lines. Yeah,
There's only 3 lines. Okay.
Yeah, there's not
Okay. If you want, guys, if you want, just add. We can like write for the last one the -3 and the 0. Write it in and just add the line.
Okay, so that's it. That's a mapping diagram. Okay. Any question on what that is? Okay, it's a little bit more work. Okay, it's definitely more writing and drawing than just listing coordinates. So we're not going to have you make one of these for like 50 coordinates.
Yeah.
Okay, 3, 4, that'd be the most coordinates you'd ever have.
And I think most of the time it's gonna already be done for you. We just might ask you to identify some stuff from the diagram.
Okay, does everybody have that? Okay, so there's our example. All right, so now we're going to look at some mapping diagrams. We're going to try to figure out, does this diagram represent a function? Okay, same question you answered in last night's homework. So we looked at it visually. Okay, like in this one, we identified this was a function because none of the x values repeated. Also, nothing lined up vertically. Right? Well, now we can do the same thing with a mapping diagram. Okay, there's a couple ways you can do it. Once you get comfortable with a mapping diagram, you can tell just by looking at it. If you're not sure, maybe we want to list out the coordinates and see if anything repeats. Right? Somebody give me the first coordinate that first arrow represents. Victor?
2, -3.
2, -3. That's that first coordinate in the mapping diagram. Sabrina, can you give me the next one?
-2, 5.
-2 matches up with 5. Okay, and Justin, can you give me the last one?
0, -2.
0, -2. Do we have any x values that repeated? No. So is this a function, yes or no? Yes, this is a function. Okay, none of the x values repeated. Okay, each one was used only one time. All right, just looking at that quickly, anybody have any thoughts?
So you can just go back up real quick second. You guys you have that right below the one we just did, the mapping diagram we just did. There's 4 of them, right? So that one right there is gonna go like in the top left. It's like sectioned off with 2 lines. That one right there will go in the top left. And the next one we do will go in the top right. So we're just working our way across.
All right. Any thoughts just looking at this one? It looks a little different. Something here is happening that didn't happen in the one above it. Ryan?
Well, basically it's you put 9 on both 3 and -3.
Yeah, if we were going to write this as a coordinate, we use 9 with 3, and we use 9 with -3, and we use 0 with 0. So what does this tell me?
That it's not a function.
This is not a
Yeah.
function. Nice.
Thanks, Ryan.
Okay, so visually, the way you can tell on a mapping diagram, if you have a number on the left and it's got 2 arrows going out of it, like that, not a function. Okay, so if you have a number on the left and it points to 2 different things, it's not a function. Okay, any question on that one? So that's it. Just all you have to say is not a function. You don't have to list these coordinates if you can see it in your head. Okay, I just did that to kind of help you guys out. But you don't have to do that. Okay, same question again. Okay, I want you to look at this one carefully. It's a little different than either one we just looked at. Okay, look at them and ask yourself, if I were going to write all the coordinates down, is there any x value that's used twice? Okay, is there any x value that's used twice? Yeah.
Would it be no? Wait. If I know that the way it would be right now, wouldn't it be 3, 2, and then -4, 2?
Yep. And what about the last one?
And then 5 and 6.
And 5 and 6.
And then it would be a function.
Why? Why would it be a function?
It's getting repeated.
Yeah, nothing in the domain gets repeated. Okay, so this is a function. What does get repeated? Something gets repeated. Yeah, 2 gets repeated, but where's 2?
It's on
It's on the what?
the range side.
That's on the range side. Okay, so in this case, you got 2 different arrows, one at 3, one at -4, both going to the same number, that means something in the range is used twice. Everyone see the difference between this one, okay, which has 2 arrows on the left going to 2 different numbers, versus this one. Okay, little bit different. You got to look at it carefully. Okay. How about next one? Is this one a function or not a function? Kevin?
No, it's not a function.
Nope, not a function. Because I look at 16 and I say to myself, what's it paired up with? Just tell me the one thing. And I can't. It's paired up with 2 things. All right, so this is not a function. Okay, not a function. Okay, and how about that one? Function or not a function?
Yeah, guys, don't worry, this last one, we're just gonna do it on the board, don't worry about it.
Jalen?
This one's on your sheet. The one we're doing right now, guys, is not on your sheet, okay? Don't worry about it, we've done like 4 of them already.
Yeah, this one you said was, yeah, this is a function. Each value in the domain is paired up with exactly one value in the range. Okay? Any questions on that? So we feel like we got the hang of a mapping diagram?
So guys, when we're looking at these mapping diagrams, when is it not, visually, when is it not gonna be a function? You can tell me. What's it gonna look like? Alexis? Exactly. When you have one number in the domain and there's 2 lines coming out of it pointing the numbers in the range. Like the one on top right there with 16. You could have 3 arrows. I don't think we'll get that, that technical, but you could have it. If you have more than 1 arrow coming out of a number on the left of the domain, then it's not going to be a function.
All right. Good with that? All right. All right, so now this mapping diagram, I gave a name to it. Okay. Did anybody see the name I gave to it? Just gave it a single letter name. Yeah, I just called it mapping diagram F. I could use mapping diagram G, F, H. I can use any letter I want. I just picked F. All right. So in this diagram,
You guys have this on your sheet on the back side.
it says -2 in the domain corresponds to what? Who can tell me what -2 matches up or corresponds with, Rose? Yeah, -8. Okay. -2 in the domain corresponds to -8 in the range. Okay. 1 in the domain corresponds to 4 in the 4 in the what? Range. All right. So basically, each number in the range, okay, is called a value of the function.
All right, so guys, you have those couple bullets on the top of the back side of the notes. Caitlin, what's the first one say? The first bullet. Yeah. So what do you think you're gonna fill in that first blank with?
Oh, correspond.
Yeah. The first blank you're gonna put in correspond. Corresponds just means like matches up. You guys have already done that. Mr. Hager had you guys listing coordinates already when we were doing the ones earlier. And then that last blank, each number in the range of function f is called a what? Who can tell me? Logan? Yep, value of a function. There's 4 spaces there to fill in. Value of a function.
Okay, and as I said before, this particular function we called function f.
That's the name that Mr. Hager and I just gave it. You might get G sometimes, you might get H. I mean, the number doesn't, I mean, the letter doesn't matter an awful lot.
Right, so if we're looking at our diagram, okay, when the value in the domain, okay, when the x value is -2, right, we can see that the value of the function is what? -8. Okay, it's a different way of saying it. When x, or when the domain value is -2, the value of this function comes out to -8. Right? This is our notation for how we write that. This letter right here is the name you gave to the function. Right? So maybe we should label that. Okay, this is name of function. This is an x value, or a value in the domain. And the -8, if this is an x value, this would be in the range. Yeah, this is the y value. Okay? So f is the name you give to the function. -2 is the x value. -8 is the y value. Right? And the way you pronounce this, you don't pronounce it f parentheses -2 equals -8. You pronounce it with the word of. F of -2 is -8. Right? That's how you say it.
You guys have that, you guys have that already on your notes.
F of -2 is -8. Okay, has anybody seen that notation before? F and then in parentheses put a number and then equals another number? Couple people? All right, so yeah, it's probably maybe new, but we'll get used to it. Try a few examples. All right, so let's see if we can figure out these two. Somebody just tell me, how do I pronounce that? Just what you can see on the left there. Yep, F of 1 is, now let's look at our diagram. If you plug 1 into function f, what is the value? What do you get? 4. Okay, so what I can write is f of 1 equals 4. The value of the function, when you plug 1 in for the domain, is 4 in the range. Okay. How about the last one? Ben, can you just pronounce that for me?
F of 3.
Perfect. Is, let's go up and look.
Do you want me to say it?
Yeah,
12?
f of 3 is 12. Perfect.
The thing of the function almost like a vending machine, right? You put in 3, goes through, what do you get? You put in, $1, hit a button, you get something.
Yeah, and that's a good way to think about it. We're going to talk about functions when we write them as an equation, and we're going to think of it as putting something in and getting something out. Exactly. Okay, any question on that notation? All right. So who can tell me here by looking at this? Okay, looking at our diagram, they want the value of the function when you plug -1 in for x. Okay, what's the value of this function if you plug -1 in for x? Kevin? 2. Okay, and now somebody besides Kevin, can you pronounce what he just gave me? Pronounce that whole sentence right there. Yep. Perfect. F of -1 equals 2. Okay? Simple way to say that, if you plug -1 in for x, you're going to get 2 for y. That's the coordinate. Last one. F of -3. Yeah, if we plug in -3 for x, we get 1 for y. So, what is this? How would you write this as a coordinate? f of negative 1 equals 2. What does that really mean as a coordinate, Kevin? Negative 1, 2. Okay. What is f of negative 3 equals 1? How would you write that as a coordinate? Yeah. Comma 1. Perfect. Okay, I have a lot of people, even students that get into like Algebra 2, they look at something like this, and they have no idea that it means that. This is just a coordinate. Okay, these are all different ways of doing the same thing. Whether you do a mapping diagram, function notation, coordinate notation, or even graph it. All different ways of doing the same thing. Okay?
And I know guys, it can be a little confusing because you have that F at the beginning. That number next to it is still the first coordinate. It's still your X coordinate. Right? You're gonna see once we get into doing like equations for this, you're gonna start plugging in that number, right, that's in parentheses for X to solve. Right? So it still means X, it's still that first coordinate.
All right, what's different about this one? This is the first time we've used this. Yeah?
There's a G.
Yeah. This time, instead of calling it my mapping diagram F, this is mapping diagram G.
Yeah.
All right? So the letter is a good thing because if I had two on the page at the same time, I could say, look at mapping diagram F, or look at mapping diagram G. Okay. Gives me a way to specify which one I'm talking about. All right, G of 2. Anyone think they can tell me G of 2? Michaela? Yeah, negative 1. Okay, G of 2, that's negative 1.
How's it negative 1?
Well, basically,
Oh, I see.
2 is your x value. Matches up with negative 1, that's your y.
I was looking on it.
All right. Okay, G of negative 4.
I think Chloe wants to give it a try, Ms. Hager.
All right?
So
So-
G of negative 4, what'd you get? G of negative 4, she said 5.
5. Everybody agree with 5? Anybody get anything different? All right, good.
Well,
G of negative 4 gives me 5. Okay, what would that be as a coordinate again? Just remind me of that last one. If I just gave you like a bonus question and I said, graph that.
It would be negative 4 and 5.
Negative 4, comma 5. Okay, so don't get confused because it's a new notation. Just a different way of doing it. All right, let's see what else we got. All right, so the last way we can represent a function is by writing an equation, okay, an algebraic equation. Okay, we're not going to draw a picture. We're not going to make mapping diagrams and draw arrows.
We're not drawing pictures.
Yeah, no more pictures. We can still graph some stuff. We'll still do some pictures. We'll keep you happy. But an algebraic expression, this way is very useful. Okay, the reason this one is useful is because I can take something that's an algebraic expression. This is way more complicated than what we're going to do. And I can plug it in on a calculator. And the calculator can make the picture for me. All right, so if we can get an algebraic expression, here's one that's a little simpler we might see. It's like y equals mx plus b. How many people remember that? Slope and y-intercept? Yeah, slope 3, y-intercept 2. If I can find a formula like this, then the calculator can make a picture for me. All right? So this way is very neat. Okay, it's good because we can do some other stuff with it. All right. So I want you to look at the following function. These are going to be the values in the domain. Okay, so we got 7 of them. Okay, 7 different values in the domain.
Hey guys, domain is what coordinate again? X, good.
Okay, here's a formula. Okay, this formula, I want you to think of it as directions. It tells you if you plug a value in for x to find the value of the function, what do you do to the x value? This formula tells you right here. take x and do what? Hey, you're going to add 2. Right? Bless you.
Thank you.
All right. So basically what this means is for each number in the domain, for each x value, the value of the function is found by using this formula right here. Take x and add 2. That's how you get the value of the function. Okay, so let's try a couple. Okay, what if I asked you to find f of 5? Okay, now you don't have a mapping diagram. You can't look at the 5 and follow the arrow. What would you have to do with the 5? Yeah, you'd plug it in for x in both spots. So now instead of f of x, it's f of 5. And what would be on the right-hand side? It wouldn't be x plus 2, it would be 5 plus 2. So now f of 5 would give me, what's the answer? 7.
You guys, this example. Here's the next one.
Okay, does everybody see that? Same question you guys were just answering. Okay. Find the value of a function, except now you just don't have an arrow to follow. Okay, you're just going to plug it in and find it yourself. Let's try f of 12. Okay, so how would I do f of 12? What's the first thing I got to do with the 12? Okay, I got to plug it in for x. Plug it in there. I'll plug it in there. So now I don't have f of x, I have f of 12. Okay, and Alex, how would I get f of 12? What would the formula on the right be?
12 plus 2.
Yeah, it would be 12 plus 2. Right? And that would equal 14. All right, so there's my answer.
So do you just plug every number with where x is?
Yep, everywhere you see an x, you just plug in the number.
Victor, we may not ask for every single number in the domain. We might only ask for, two, like this one, we only ask for 2. We didn't ask you to do every
Do
single
they have to
one.
be like certain ones though?
Yeah.
Yep, you'll have a list of specific numbers I ask you to plug in. Just like that.
All you're doing is taking what that number is and plugging it in for x. That's all you're doing.
So this one I'm asking you to do every single one.
And this one, guys, you have on your notes. It's in the bottom left-hand corner.
Okay, I'm going to ask you to do every single value, but there's only 3. Okay, we only have to do 3. Right, so they gave me a function. They gave me a formula. This formula tells me what to do. All right? To get these 3 values, I got to take -2, 1, and 3. Plug them in, see what I get. All right, Justin, can you tell me how I do? Let's just start with f of 3. How do you get f of 3? What do you have to do with this 3? Okay, look back at what we did on this one. How did we do f of 5? What did we do with the 5?
You put the 5 in the spot of the x.
Yeah, exactly. You take the 5 and we put it in place of the x. Okay? So I want you to do the same thing here, except this time it's not a 5. What number am I using? 3. And I'm going to take the 3 and do what with it?
Put it in the spot of the x.
Put it in the spot of the x. So can you tell me what I would have if I do that? You don't have to simplify it. Just do exactly what you said. Put 3 in for x.
So it would be 12 squared.
Don't do any arithmetic. Literally just change that to 3. Just set it up.
So 4 times 3 squared minus 1.
4 times 3 squared minus 1. Okay, so that formula told us what to do. Now we got to do it out. All right, so we talked about this earlier. First thing I do here is what? Yep, my parentheses, my exponent. Right, so Michaela, what's 3 to the second power?
Wait.
Careful, not 3 times 2, 3 times 3. 9. Okay, and how about Callan? 4 times 9 gives me? Okay, you want to help her out? What's 4 times 9? Kevin? 30 what? 36. Take away 1?
No, sorry,
35. All right. So if you plug in 3 for x, you get 35 for y. That's the value of the function. All right. F of 1. How about Sam? Can you guide me through how to do that? Yep. Good. Minus 1. So that's our setup. Okay, we plugged 1 in for x. Okay, Ariana, can you give me my next step in simplifying that?
That's 4 times.
Good. Do your exponent, and you said it's 4 times 1. Yep. Okay, and now my last step. How about Alexis? What do I do first? 4 times 1 or 1 minus 1? Yeah, always do your multiplication first. Okay, 4 times 1 is 4. Take away 1. 3. Okay, so this one says if you plug 1 in for x, you're going to get 3 for y. All right, next one, be careful. Okay, it's a negative. All right, so we're going to just maybe use our calculator, be careful. But yeah, Victor, you want to just set it up for us?
Yeah. Would it be 4, -2, -2,
Yep, your exponent or your power, yeah?
The mini
minus
2.
1.
Mini 2. Nice, perfect. That's exactly what you want to do. All right, now my next step. Be careful with your exponent. What's negative 2 to the second power? Negative 2 times negative 2. Positive 4, good. All right, now we got 4 times 4 gives me 16. Take away 1. 15. All right. So that's 3 particular points we wanted you to find. Okay? We could have asked you plug in 0 for x, plug in 7. Okay, we could have asked you any number we want. Okay. You guys want to see what this looks like if you draw a picture of it? This isn't y equals mx plus b, is it? You don't want to see a picture? Why not? This is a really cool picture. I'm excited to show you this. What? Yeah, I might just do the picture, all right.
He wants to show off his calculator skills, that's all.
Okay, everyone see how that one's aligned? Okay, nice straight line. Putting this mini 2, as Vic says, put the mini 2 here. This isn't going to make it a line anymore. This is going to make it a curve. There's our picture. Okay. It's kind of this curve shape. Okay. And let me show you one other thing this calculator can do. Tell me, what was one of the numbers we had to plug in for x? What was one of the numbers we had to plug in for x? Victor?
-2.
-2? Did we get 15 when we plugged it in? Look at that. What was one of the other numbers we had to plug in? 3? Did we get 35? Yeah. So what's nice, if you ever use one of these, maybe in Algebra 2, you can set this up on your calculator, and then I can just keep plugging in whatever numbers I need to. Okay, and it'll do it for me.
How much does it cost money to get that calculator?
This one's free on the computer, but yeah, if you wanted to actually buy one, yeah, they're expensive. like $100.
Jeez.
Yeah.
Calculator?
Yeah, it does a lot of different stuff. It's pricey.
No, that's free.
All right, but for the ones the ones we do in class, we're going to keep the numbers pretty small. So you're going to be able to do the arithmetic with just a regular calculator. You're not going to need one of those. Any questions on those? All right. This is our last one? Yeah. Okay. Why don't you guys give this one a shot?
Yeah.
Okay. Here's your formula.
It's gonna exponent just like the last one.
We give you three numbers we want you to plug in. -3, 0, 3. Find those y values.
I didn't even eat
All right, guys, listen. This is what we got. Logan, you all set, man? Henry, you're rocking that tie. You're all good. So this, guys, this is what's gonna happen. We're gonna go.
Sorry.
Thanks, Vic. All right, I wanna go over this one. All right, we'll talk about a few little updates at the end of class. We'll give you the homework. On the back side of the homework, we're gonna have you guys like do 3 more practice problems on your own, right? And that's it. All right, still got about 15 minutes left, just so you guys know what's going on. So let's do this one. So we have them all listed out. G of -3, G of 0, G of 3. Who can tell me this G of -3? What's that equation gonna look like? When I write it out, Victor.
G -3 equals -3 and -3 to the, that's the 2,
All right, should I do anything here to kind of separate it a little bit?
parentheses,
Yeah. Let's do parentheses. Inside the parentheses is going to be what, Victor?
-3
-3, yeah.
equals -3.
You want a mini 2 up here?
Yeah.
And then,
-3, right?
yeah, I got to have all that. What's left? I did this, I did this, I did this.
Okay, plus 6.
So that's my first one. That's G of -3. That's what it looks like. All I'm doing is taking this, plugging it in for X. That's all I'm doing. All right, how about, Justin, can you help me set up the equation for G of 0?
Yeah.
Okay.
So, you do 3.
What am I going to start with? Good. Then what? Then what's next? And then excellent. Kev, can you give me the last one?
Last one.
Yep. So I did -3. I did 0. I have 3 left. G of 3. What's that going to look like?
G of 3 equals -3.
Yeah.
Parentheses 3.
Yeah. Yeah.
Then
2.
Mini 2. Victor's mini 2.
Plus 6.
Plus 6. So there's my 3 equations right there.
You don't have to solve it.
Well, we do have to solve it. I want to set them all up first. I'm not letting you off that easy. All right. So what I'll do is, I'm going to bring down the first one. G of -3. Who could tell me? What's the first thing I should do? Vic?
Parentheses
All right. What am I going to get?
would it be -6?
No.
9.
Good. Remember, -3 to the second power. What does that mean?
3 times 3.
Careful. Close. Good, Sabrina. -3 times a -3. Whenever you have a negative, we call this like a negative whole number or a negative integer in an even base, your answer is always going to come out positive, right? Because 2 is an even exponent. If I have a negative base and an odd exponent, my answer is always going to come out negative, right? So if I had like -3 to the third power, it's negative 3 times negative 3 times negative 3. So I get positive 9, but I still have that negative. I still have that one negative that didn't match up. That would make the whole thing negative. So here I'm going to get 9. So I'm going to keep my parentheses around it because I know it's multiplication. Negative 3 plus 6. That's what I have so far. All right? What am I going to do next? Sabrina? Negative 3 times a positive 9. What do you get, Sabrina? Negative 27 plus 6 equals, for this, negative, right? Negative 21. We talked about this earlier in the year. Ignore the signs for right now. 27 is bigger than 6. 27 has a negative sign with it. That means my answer has to be negative. I just read it backwards. I put my negative sign first. 27 minus 6 will give me 21. If I know by looking at it, 27 is bigger than 6, I know right away my answer's got to be negative. So I put my negative sign first. Now I just read it backwards. 27 minus 6. So negative 21 is one part of my range. All right? Guys, I'm not going to go through the whole things. I want to get the ones that we're going to do at the end aren't as involved. But I know that you just got to understand when you're doing these, you got to understand how to work. You got to understand how to work with your exponents. For the next one, anybody solve for the next one? What you got?
Okay.
G of 0. Yeah, so guys, G of 0 should have equaled 6. Then you got G of negative 3. Anybody get G of negative 3? Anybody get G of negative 3?
Yeah, it's negative 21.
Yep. All right, guys, so for these, listen, gauge, please. G of 3 should have been 21. Negative 21. G of 0, 6. G of negative 3, negative 21. All right? So that's it. All right? Guys, I'm going to give you the homework. I want you to go to the back side of the homework. I want to do you still got a little bit of time. We still got like 10 minutes. We'll do a couple more practice.
Okay, so what Mr. Rice passing that out, couple quick reminders on the board. Half day on Friday, so we're going to do our test Thursday. Okay, no class Friday. Grades closed, so anything you got to make up, make sure you come see me by Friday. Otherwise, after that date, once grades close, it's a 0. Okay?
All right, guys. So whether you're in the back side, you can use your notes for this. That's fine.